I'm Amelia Dalton from eejournal.com on the scene with Ben Jordan from Altium at DAC 2014. Thank you so much for joining me today, Ben.
Thank you. It's good to be here.
So, Altium has a brand new version of Altium Designer just released. Quick, show me the 3 coolest things that you can right now.
Okay, so, well, as some people may know, we've had since late last year a really powerful rigid flex design capability where we can model a flexible circuit in 3D. And so with this latest update, one of the biggest, coolest things that's come out with that is we can export that assembly in a folded state to bring into any mechanical CAD package, so you can do true clearance checking without having to find some ways of bending it up in the MCAD tool as well. So that's pretty powerful. In addition to that, we're closely working with more and more development partners. One of the things we announced also later last year was a developer network and development program. And so we're partnering with in-circuit design. This is actually not released just yet, but it's almost there, for a really powerful layer stack planning tool called the in-circuit design layer stack planner. And it models in using a field solver the impedances of the traces and differential pairs you design into your layer stack. So that's a very powerful tool. What else is there? We're adding some more high-speed and RF design capabilities. We've also just released in Altium the ability to do RF transmission line traces with the proper chamfered corners, and the ability along with that to do bandpass filters, directional couplers, antennas, that kind of thing in the PCB Editor directly. So it's going to get a lot quicker and easier for people who are, you know, this world, whether we like it or not, is getting more and more wireless every day. So, and a lot of that comes down to the PCB, so people need that capability.
So do you have a demo you can show me real quick?
Sure. Yep, I'll give you a quick look at some of these things. So, of course, here's our 3D PCB editor, and as you're aware, we can fold up our different sections of the board, and of course, we could put that in whatever position it's ultimately going to be in and save that out as a step file. I don't have the mechanical CAD loaded on this machine right now to show it in the MCAD tool, but there's a video showing that off on our website. Going back to another PCB design, if I need to do some power distribution network planning on this board, this new ICD stack-up planning tool, again, it's a third-party plugin. It's allowing me to define all the conductors and materials used in the board, and it has a very large library of materials along with their electrical characteristics and dielectric characteristics. So I can plan differential and single-ended impedance of transmission lines on those layers and have a very closely controlled, impedance-controlled layer stack. In addition to that, there's a power distribution network planner here. The Pdn Planner actually simulates a given power plane in my board layer stack. So I'm looking at the VDD power supply on my board in my 12-layer stack up here. And it's showing me the simulated, based on the 2D solver, impedance of that power plane. So I can see that the impedance is minimized at around 200 megahertz. So that might be good for a traditional digital or mixed signal PCB, but maybe not so good if I'm doing 10 gig Ethernet or something like that. So what I want to do is see how is my decoupling going to improve the impedance. So I click on the little capacitor button here, and there's a big library of capacitors of all different popular brands, such as Kemet, with different materials, and all of their characteristics in terms of impedance and ESR, etc., is here. So I can add a capacitor to that plane, and it shows me how the impedance has been dropped down lower, but it's now bottoming out at a much lower frequency. And a lot of engineers like to put big caps in parallel with small caps. So if I add another big cap there, I can look at that. Now it's showing me, yes, it's given me 2 troughs in the power plane impedance, but now I have this big spike in between those, so that's not necessarily going to be the best thing for my design. It depends. So I might go back and choose a different decoupling strategy. But the really nice thing is you can very quickly get an idea of what decoupling is going to work, and what signals you have to be careful of there.
Well, I think that's all I have time for. Thank you so much for joining me, Ben. It's always a pleasure speaking with you.
And always with you. Thank you.